Hello everyone. This is Dhanalakshmi, Assistant Professor of Triple Department from RMD Engineering College. In this session, I would like to discuss about I2C bus, which is otherwise called as an inter-integrated circuit bus. Right, in embedded systems, where in Unit 2, already we in the previous video we were discussing about RS-232 standard, which is a serial communication protocol. So in this session, I would like to discuss about I2C bus, that is inter-integrated circuit bus. Right, I2C bus, when you take it is IIC, right? That is inter-integrated circuit bus, which is a synchronous, right? These are the features we have for I2C bus, where it is a synchronous. So as we know, it is going to do synchronous communication. Whenever we say synchronous communication, always the clock signal have to be sent along with the data, right? Whereas in case of asynchronous communication, there's no need of a clock signal. But when you have a synchronous communication, when you're going to do synchronous communication, it should be of clock signal always should be sent along with the data, where data and the clock signal have to be synchronized. That is the device which is going to communicate have to be synchronized with that device. So that's why we have a synchronization. We have to do a synchronization with the help of a clock signal. And it's an off-duplex concept where, and as we know already, off-duplex is something where the data can flow in both the direction, but not simultaneously. At a time, data cannot flow in both the direction, but data can flow in both the direction. And it's a serial protocol. It's a serial communication protocol. It's a byte-oriented one. Where it's a, when we talk about I2C, it's of a two-wire protocol. The two wires are SCL and SDA. SCL is for serial clock wire, and the other one will be serial data wire, right? So we'll discuss those things in detail. And we have three standards here. One is slow, fast, and high speed. Slow is where 100 kilo BPS, 100 kilobits per second, it is said to be slow. Where if it is around the 400 kilobits per second, it is said to be fast. And if it is in megabits per second, that is 3.4 megabits per second, it's said to be high speed. Right. So this is about this is the connection where we can see for I2C bus, you can see that here we have a master, and these are the two lines, serial clock wire, and this is a serial data wire. So where in serial clock wire, where clock signals will be sent, and serial data wire, data and address will be sent, right? So here these are the two buses, these are the two wires which forms your I2C bus, right? And these are our pull-up resistors where it is connected. You can see that the VCC is connected through our pull-up resistors. Here it's a single master and multi-slave system where one master communicating with n number of slave devices. So you can see slave 1, slave 2 up to slave n devices, where here we have a single master. Right. So here you can see the communication, how it is broadcasting, how the start condition has been, how the master is communicating with the slave devices, right? How the how it is doing the communication. So here you can see that. So whenever the first point is whenever the master wants to initiate a communication, it will be making this STA line to be low. Right? Second, let me take the pen. So what this will do is, whenever master wants to initiate a communication, it will make this STA line to be low. So once this master makes the STA line to be low, and where STA line is high, it means that it is initiating the communication, right? After this, when the STA line is made as low, all the slaves will come to the attention and they will listen to the master, right? So for example, if I have a number of slaves and there's a single master multi-slave system, so when master initiates this communication, all the slaves will come to the attention and will listen to the master. So, and what the master will do is the next immediate bits will be our address bit. So it is going to send a 7-bit. It is going to send a 7-bit address, right? It is going to send a 7-bit address. So you can see that from 0 to 6 bits, right? So from 0 to 6 bits, it's 7-bit address, right? So immediately after this STA line becoming low, the next will be, it is going to send a 7-bit address, right? So the 7-bit address is sent here. And then the next immediate, you can see that this is our STA line, right? Through STA line, it is sending data and address. Whereas the other line will be our serial clock line, where you can see that the clock pulses, right? Here you can see the clock pulses are given. So at each and every clock cycle, you can see the bits are transmitted. The bits are transmitted, and you can see that whenever the clock signal or whenever the clock pulse is getting from low to high transition, the bit will be transmitter. You can see that. So each and every clock signal will transmit a bit here, right? So therefore, for the next meet after the communication is initiated, it is going to send a 7-bit address. Then after 7-bit address, then it is next is will be our R bar W, which means the read or write, in which it is going, that is either it is going to read from the read or write based on the direction of data flow, whether the master is going to read it from the slave or it is going to write it to the slave. So based on that, the read write communication will be taking place, right? So read write communication will be taking place. So it will be sending whether it is going to read the data or it is going to write the data. Then comes your acknowledge, right? Then comes this acknowledge, where in this point, this is since this master is going to send the 7-bit address no, this 7-bit address will be getting matched with one of the slave. Right. So this broadcasted address will get matched with the one of the slave, because the slave, only one particular slave will be carrying this address, right? So whenever the sent address is getting matched with, or whenever the sent address is getting matched with that particular slave, that slave should acknowledge, right? That slave should will acknowledge here. So the acknowledge signal will be sent by the device, whichever device is receiving, right? Whichever device is that is whichever slave is receiving, right? So this 7-bit address will get matched with a particular slave, and that slave will be acknowledging. Right. After that, you can see that this is the continuation of this one. After that, the data will be sent, right? If it is going to read it, the slave has to send the data, or if the master is going to write it, the slave will receive the data. So, right, you can see that 8-bit data from D0, right? D0 bit to D7 bit, the 8-bit data has been sent. Right. So the 8-bit data has been sent, and once the data has been received, it has to send the acknowledge signal. Like this, it will be keep on sending the data. Once the transmission is over, right? Once the communication is over, once the data has been transferred, then comes your STA. Then again, it will make this STA line to be low, right? You can see that it is making this STA line to be low. Once it makes STA line to be low, it means that it's going to stop the communication. Right. So here at the initial step, when it makes the STA line to be high, STA line to be low, which means that it is going to start the communication. And once the communication is over, again, this STA line will be made as, low, which means that it is going to stop the communication. After that, the STA line will be high, and also the SCL line, that is serial clock, right? Serial clock as well as STA line, both will become high after this. After the stop condition, you can see that both the lines, STA line, serial data line, as well as the serial communication line, both becomes high. So this is how it is communicating. So, right. So initially SDA line will be made low, which means that the master is initiating the communication. Then it will send the 7-bit address. Then it will be telling whether to be read or write, and then the particular slave device has to acknowledge it. Right. So you can see that the particular slave device has to acknowledge it. Then after that, the data will be sent, and once the data is received, again it has to be acknowledged. And finally, once the communication is over, the SDA line will be made low, which means that it will tell you that it is going to stop it, right? Stop condition. So after stop condition, you can see that the SDA line as well as the SDA line both will become high. So this is how it is doing here. So here you can see that this is how it is communicating. Single master communicating with the n number of not 10 n number of slave devices. Right. So this is the steps in which it is communicating. That is what we discussed in the earlier. So you can see that. So start condition, then the slave address will be sent, then read or write. Okay, let me take a pen. You can say that this is our start condition. Then 7-bit slave address will be sent, then read or write, which action has to be taken. Right. Then once after that, the particular slave will be acknowledging, then the data will be transferred. Once the data is transferred, at each and every time the data is transferred, it has to acknowledge it. Once all the steps are being, if it still has to communicate, if it still has to send the data will be sent again, and finally it will be receiving the acknowledgement. And once all the communication is over, it will go for the stop condition. So this is what is given in the previous speaker. Right. So this is our I2C bus, where you can see that here the one particular thing what we have to discuss is NACK, right? Once again, right. So this is what, right? NACK, it is a negative acknowledgement, right? It's a negative acknowledgement. If you can see that it is a negative acknowledgement bit from the master. If this pin is active, then acknowledgement after a transfer is not needed, right? So NACK is a negative acknowledgement pin, where if this pin is active, then each and every time, that is after the data is transferred or after, then acknowledgement is not needed after a transfer. That is about the NACK, right? From the slave. So the slave need not send the acknowledgement if this pin is active. After transfer, the slave need not send the acknowledgement if this pin is active. Otherwise, it has to send the acknowledgement. Right. So you can see here, this is our I2C connection, where already we have seen the same thing in the first slide, where we have a pull-up supply VCC and a pull-up resistor. For each and every slave device, there will be a separate clock in, clock out pin, as well as data in, data out pin. So this is for device 1. Similarly, this is for the next device. So we'll be having, it's a 2-wire protocol, where the 2 wires are SCL, serial clock line, and the serial data line. So you can see that from the serial clock line, you can have serial clock in, clock out, and similarly serial data line, where you have a data in and data out line. Right? Thank you. Thank you so much.